Hello everyone! In this video, we are going to talk about application of differentiation. But before we start, let me introduce you to our group members. First, we got Shaza Shahira binti Azizan, matrix number 2020858046. Next, we got Lutfur Rahman Ansari bin Patahor Rahman, matrix number 2020443204. Lastly, we got Vernal Siwinol, matrix number 2020458526. First and foremost, praises and thanks to the God for His showers of blessing throughout our research to complete the works, and we are really grateful because we managed to complete this video presentation. Secondly, we would like to express our special thanks of gratitude to our lecturer of Calculus 1, Dr. Liu Chenying, who gave us the golden opportunity to do this wonderful project and willingness to help us in what are we lacking when completing this assignment, also surely for teaching this course. Last but not least, we also like to thank our family members who keep on encouraging us all the time. So, what is differentiation? Differentiation is a process of finding the derivative or rate of change of a function. The topic that we will discuss in this video is apply maximum and minimum problem, which is one of the subtopic in application of differentiation.
Alright, to give all of you some context, what we're going to present today is one of the applications of differentiation in the fundamental theorem of calculus is applied maximum and minimum problem. This is what we're going to present today. The process of finding maximum and minimum value is also called optimization. Like for example, the uses of optimization in the company are we have to do things like maximize the profit in a company or minimize the cost or find the least amount of material to make a particular object. So it shows here that these are very important in the world of industry. They also can be applied in our daily life too.
Problem statement is Abu wants to buy a closed cylindrical barrel of radius x centimeter and height y centimeter, given that y is 600 over pi x square. First question is prove that the surface area a centimeter square of the barrel is 2 pi x square plus 1200 over x. Next, find the value of x centimeter, which is radius, and y centimeter, which is height, that minimize the total surface area of the barrel. Hence, find the minimum surface area of the barrel.
So our objective is to use the method of applied maximum and minimum problems to solve applied optimization problems. Another objective is to determine the value that minimizes total surface area of the barrel. And lastly, to find the unknown variable by using differentiation.
So the first question, we have to prove that the surface area of the barrel is 2 pi x square plus 1200 over x. Given from the question that y is 600 over pi x square. We all know that surface area formula for cylinder is 2 pi radius square plus 2 pi radius multiplied by height. So we substitute with our height and radius, which is x and y. So it will be 2 pi x square plus 2 pi xy. And then we substitute the y, 2 pi x square plus 2 pi x multiplied with 600 over pi x square. We calculate, it will be 2 pi x square plus 1200 over x. Next is we are going to find the value of x and y that minimize the total surface area of barrel. So for the first step is we are going to find the derivative for area. We all know that area is 2 pi x squared plus 1200 x power of negative 1. Then we derive it will be 4 pi x minus 1200 over x squared. Step number 2, we are going to let the derivative equal to 0. As we all know from the step 1, our derivative is 4 pi x minus 1200 over x squared. So we equal it to 0. Then we simplify it and we will get x equal to 4.57 centimeter. Last step is second derivative test. We are going to do the second derivative and it will be 4 pi x minus 1200 over x cubed. When the x equal to 4.57 from the step 2, we just substitute it inside the second derivative and it will be 37.71, and this total is more than 0. So it means that x equals to 4.7 is a minimum value. Next, we are going to find the y values. When x is 4.57, we substitute inside the y and it will be 9.14 centimeters. So for the last question, we are going to find the minimum surface area of the barrel. In this question, it is very easy because we are going to substitute the x value from the question B inside the surface area from the question A. It will be 2 pi power multiply with 4.57 square plus 1200 over 4.57, and we calculate it will be 393.181 centimeter square.
So, for the conclusion, we can conclude that the importance of apply maximum and minimum problems, as we can see, Abu can find which cylindrical barrels meet the requirement of surface area he needed, which is 2 pi x squared plus 1200 per x. He found the cylindrical barrel surface area by only substitute the given height of barrel into the formula of area of cylinder, which is area cylinder equals to 2 pi x squared plus 2 pi xy. Next, Abu can find the value of x centimeter and y centimeter that will minimize the total surface area of the barrel. To find the values, he differentiates the surface area he needed proven by himself. After that, the derivative of surface area, which is 4 pi x minus 1200 per x squared, he let the derivative equal to 0, which will lead him to find x centimeter. Then, he can decide if the x centimeter is minimum or maximum value by doing second derivative test. He found out the x centimeter is minimum value when he gets second derivative more than 0. Lastly, he found 1 centimeter by substituting x centimeter into given height y equal to 600 per pi x squared. Last but not least, Abu can find the minimum surface area of the barrel by simply substitute the x centimeter earlier into 2 pi x squared plus 1200 per x. Therefore, by simply understanding and applying the concept of applied maximum and minimum problem in real life, it may help to solve our daily problem. So that's all from us. Thank you for watching and stay tuned.